electron, and an OH. Well, I'll just do this. The O on the OH has an unpaired electron, and then the H has an unpaired electron. Those are very unstable. So they're going to, one of those is going to wind up attacking the pi bond, break the pi bond. Now that's when this thing breaks. Now this carbon has an unpaired electron, and that carbon has an unpaired electron, which were originally bound together to make up the pi bond. So that hydrogen is going to choose which one it's going to attach to. We now know which one. And then that oxygen will know which one it is going to attach to. Mohammed? So it winds up, this OH had one unpaired electron. It gets tied up with the carbon, and then it's got, the oxygen has 8 electrons around it, and it's good to go. That makes it stable. Everybody good? There were 2 things that I wanted to mention, very short. Can I do that? Can I erase?
Yeah.
Simpleton technically means you're being really dumb, like an idiot. I'm like, yeah, I know,
I want to spend just a few minutes today getting us into the next category of organic compounds, because we're not done yet with reactions. I've stopped. I've talked about substitution and addition reactions. We have more reactions to talk about, but we have to first learn about alcohols. And then tomorrow we'll get into, well, what kinds of reactions do alcohols undergo? Alcohols are organic compounds containing OH as a functional group. If you have an organic molecule that has an OH somewhere on it, that makes it an alcohol. It's a whole class of, I mean, you can imagine all the organic molecules you've seen already, you can put OHs in lots of different places. So there's many, many kinds of alcohols. The nomenclature for alcohols goes like this. You're going to end the name of an alcohol with, not the word alcohol, just OL. The systematic name would just be OL at the end. So that the simplest alcohol is this. That would be an alcohol. What's this one? Methanol. Methanol. So you keep the methane, you just add the ol at the end. Now, specify which carbon the OH is attached to. Sorry. What's the name of that compound? 3-hexanol. 3-hexanol. You've got 6 carbons in a parent chain. We got an OH there on one of the carbons. This thing would be 3-hexanol. You follow? Systematic naming. Lennon. You're not going to deal with those. Nope, you're not going to have those. Is it possible? Yeah, those compounds exist, but we're not doing that. Yes.
So, for example, there was a hydroxide on the second one too. Would that be like 2,3-hexanol, dihexanol?
We're not going to see any diols either. An alcohol that's got 2 OHs on the same molecule is called a diol. The most common diol is one that you know. Well, you don't know that you know it, I guess, maybe. Maybe you do know that you know it. That thing right there is called ethylene glycol. It's in radiator fluid. That's what our cars have this inside of them. It's our antifreeze in your car. It's ethylene glycol. Yeah. Used in what? Medicines? Yes, I have heard of it, and I don't know. I don't know what the use is. Yep. Yeah. The propylene glycol would be 3 carbons sandwiched in 2 OHs. Yep. But this thing, the official name, the common name is ethylene glycol. The official name of it would be ethane diol. The di meaning 2 OHs on it. Ethane diol. Okay, I got one more for you to name. How about if I'm going to erase this and erase that, and put that on there. What's the name of it now? I'm going to tell you this. When you recognize that you have an alcohol in here, then I want you to make the alcohol and the OH part of the parent chain. Assume that that's the parent. Now name it.
Oh, 5-methyl-3-hexanol.
Okay, now I'm hearing what you're saying, and I'm glad that you're saying what you're saying, even though some of you are wrong. Some of you are struggling because you don't know if that's carbon number 1 or if that's carbon number 1, right? I can hear that. Because this one, it looks like it's closest to the functional group. However, the alcohol gets the priority, just like double and triple bonds do, for the numbering. This is the parent chain, so since the OH is closer to that carbon than it is the other carbon, that becomes carbon number 1. The name of this thing would be 5-methyl-3-hexanol. Good? 5-methyl-3-hexanol. That right there is considered the parent, the 3-hexanol, or whatever functional groups are on that. Yes? Go ahead.
Whenever you have an iso with the OH, you don't want the one out, like for isopropyl alcohol.
No, I want to talk about iso right now. This will be the last thing, I promise. Can I erase this in black?
Yeah.
You don't need to write this down. I'm not counting my carbons, I'm just making a bunch of carbons in a row. And if I have this long chain of carbons, and then I have a functional group on it that looks like this. Looks like I know what my parent chain is, this long thing. But then I have this thing as a functional group, and it looks like there's a branch coming off the parent, but the branch has a branch. Thank you very much. Recall that now. It looks like there's an ethyl with a methyl attached to the ethyl. Here's what it's called. Do you notice that this whole functional group has 3 carbons in it? But we wouldn't call that a propyl group because propyl should be CCC. This is called isopropyl. When you have a 3-carbon functional group, but the attaching one to the parent is the middle of the 3, that's called isopropyl. I don't know why. Where we got iso? Iso to me means like the same. But yeah, that's isopropyl. So isopropyl alcohol would be 3 carbons with the OH on the middle carbon. That's isopropyl. Huh? If you have something like this, this would be sec-butyl. This thing right here. Because if you notice, this is a branch that has 4 carbons on it, but the second carbon of the 4 is attaching. What does that sec mean? Secondary. That carbon's attached to two other carbons. Yes, maybe. Oh, 1, 2, 3, 4. Okay, that's my last one. This thing right here, that attaching carbon is attached to 3 other carbons. What word do we use for when they got a carbon attached to 3 others? Tert. So this is tert-butyl. I want you to know, you'll come across these terms, iso, sec, tert, maybe even other ones. I want you to see them and relate to them. I don't think it's appropriate, though, to ask about these on the quiz. There's a lot of organic chemistry we're learning. There's a lot of things I find are more important than iso and tert and all that. So now, you may be responsible for recognizing this thing, but the naming itself of it, I'm not so hung up on. Yeah.
So you don't need to know where the carbon is, you just need to know if it's connected with or
ISO, right?
Yeah, I don't know.
What are you asking me?
Do you have to specify where the carbon is coming from?
Oh yeah, sure you would. Like this would be 1, 2, 3, 4, 5. That would be 5 isopropyl.
I mean, where the carbon is attached on this, like,
This thing? Yeah, but we care about the attaching carbon. Yeah, that's what matters.
You don't have to draw them.
And wait.